Oh, we should do something special. We got a low-tech story. What's on the snipper chat today there, Sam? Yeah, I don't blame you. It's telling stories. Okay. My pants are weird at the bottom there. Okay, so our board isn't working, so we're just going to roll with no notes on the board. But you guys have your note packages. Oh, and if you check the description, I'll put the thing in the description. I've been putting the blank note packages in the description. For one unit I did this. I'll try to do it moving forward. So, let's just do some grade 10 review on trig. So I think in your notes you have something like this. So I guess I'll just have to draw it. And if I put the theta value there, can you find a couple trig ratios here for me? So in grade 10, you guys learned the whole SOHCAHTOA thing. Yeah, it's really a genius thing that this guy, the Pythagorean guy, figured out. Pythagorean guy. So if this is your triangle, now the trig you guys learned in grade 10 only works in 90-degree triangles. Okay? What you're going to learn in grade 11 is going to work in any triangle. Okay, so that's quite a jump. And then we're going to set you up for a bunch of grade 12 topics. So a couple things about how you name the sides. What's the side opposite the 90-degree angle always called? That's the hypotenuse, okay? So, and I just put height for hypotenuse. It's always the longest side, by the way. Okay? Always. In a right angle triangle. Then, depending on where your angle is, so if I'm interested in this, so we generally just use that symbol to denote an angle. The side opposite that would be considered the opposite side. No, the side opposite. Yeah, the only side that's left will be adjacent, and it should be right beside. So that's how I used to figure it out. Okay. Now, if I'm asking you to solve for this angle, the only ratio you can use, you say, well, I got opposite and adjacent. That's tan. Okay, so tangent, you would write tan theta. Well, that's opposite over adjacent, and then you can write tan theta equals, plug in your numbers, 10 over 4. Now, the million-dollar question, when you're solving for an angle, do you remember how you do it? Inverse. And you use the inverse. Okay, so you go theta equals inverse tan, so that's tan to the -1, that's how you write inverse, and then you plug in the ratio. Now, this all seems rather mysterious because it's like, what's going on? I don't know. I'm a big believer in teaching the history of how things are discovered because it actually helps you understand, but when Pythagoras, what the heck's his name? Is that Pythagoras? I also want to call him Pythagorean. So when Pythagoras figured out this rule for right angle triangles, the reason we do inverse is because he made a table. Like he had let's just say a piece of paper, okay? And what was the thing he found out? He found out hey, if you have this ratio, like 10 over 4, which is 5 over 2, which is 2.5. When the ratio of the opposite side to the adjacent side is 2.5, this is the angle. Like he literally just constructed what we think. We don't know. We think that he constructed the triangles and just measured it. And then he made a table. Right, so you have a table. Like when my mom was in school, calculators were not even existing yet, I think. So they just had tables. And the reason why it's inverse is because you're reverse looking up. So you have the angle. Okay, so believe it or not, you can do 1, 2, 3, 4, 5, 6, 7, 8 degrees. And it would have the ratio for each one. Right? So it'd be like, type this in on your calculator. Let's get an answer. The reason it's inverse is because you're looking backwards in the table. So you're looking for the ratio and you're going back to the angle. That's why it's inverse. That means backwards. So this becomes less mysterious. It's like, why do we do this? Like, what does it mean? It's because of the history of where it came from. So what do we get?
68.2.
Oh, I guess I have that on my paper. But yeah, I wanted you guys to try. Okay, so 68.2 degrees, right? So somewhere down here, it would have been 68 degrees. And then it would have been 2.5. And you would go backwards and look and be like, if the tan ratio is 2.5, the angle is 68 degrees. Okay? Now we do it on our calculator. There it is. Right? And then if you didn't have the exact ratio, like say you had 2.55, you would just find the closest one. That's how my mom used to do it. Yeah. I think does that dispel some of the mystery that in grade 10 of why it's this way?
A little bit, yeah.
If you remember that story, you will. It's like, oh, it's inverse, from the table, you're going backwards. You just need to write this, and then there it is. It's not mysterious anymore. It helped me. I discovered that by accident in high school, that by learning the history, because you remember the stories, like all these people who discovered this stuff, they had like crazy lives. Like, do you know Pythagoras had like a cult?
He had a cult?
He created a cult. And like, you know, I'm serious, like a cult, like he created a cult, and he would teach like the theorem to like the inside people, right? And then there was like these outer people that were sort of in the cult, but they weren't deemed like good enough to learn it, but like maybe one day they could. No, seriously, like it's fascinating. Einstein had like 3 mistresses or something, like, and he was just kind of like a jerk. Like it's super, if you go study their lives, like it's super interesting. It's better than Days of Our Lives on TV. So now we got this. Harlow's gonna make so much fun of me when I'm gone. I hate them, man. Okay, so this is a question where I'm giving you an angle. And what else are we giving you? This side here, and I'm asking you to find that. Okay, so more review. So right away, the first thing you should do is label your hypotenuse, because that never changes. Okay, so there's the hypotenuse. Now if I'm using this angle, I'm looking for that side, then I must use this side. So what side is this? Opposite, adjacent? Opposite. Perfect. Okay, so we're going to go opposite and hypotenuse. What ratio is opposite and hypotenuse?
Excuse the interruption.
Hello?
I'm looking for Seihu Han.
I'm not a savior.
Say
The last
who?
name is Ann, H-A-N.
Okay, yeah. Yeah, they're here.
Okay, can she come to the office, please?
Okay.
Thank you.
So what is it? Opposite x over adjacent 15. Now, no matter what, if you're trying to isolate your variable, you're going to multiply both sides by 15. So that cancels out to 1. So you have 15 times sine. Oh, I forgot to plug in the angle. So the theta, you're going to plug in the angle. Sine 39. So this is just a number. Where does it come from? The table, right? It's like 39 degrees sine ratio, and then you would get the actual ratio. So maybe that's less mysterious now. Like this guy just went and calculated them all. Now it's all in your calculator. So what's the answer?
So 9.4.
Perfect. That's what I got too. And if there was units, so if there are no units, you should just write units. Okay, great. Questions? Okay. So I think that's all the review that we did. Should we do one where the variable's in the bottom? I feel like we should. Yes, let's do that. I'm gonna add one. Let's just add one. Draw a new one. So let's just go like this. And we'll be, okay, so let's do this. Yeah. Yay! Okay. Find x. So we got opposite over hypotenuse. So which one is that? What ratio?
Sine.
Sine. So we're going to go sine theta, which is 60, equals opposite 10 over hypotenuse x. Okay. Now, I don't know what you guys did in grade 10 for this, but when you're trying, like no matter what, when you got a fraction, you're going to end up multiplying both sides by the denominator. Now in this case, the denominator has x in it, so I'm going to multiply both sides by x. X divided by x is 1, so now you have x sine 60 equals 10. Now what? There's multiplication here, right? So what's the opposite of multiplication? Division, so we'll divide both sides by sine 60. There you go, you would type that in on your calculator, and I don't know what the answer is because I just made it up. Okay, let's get some confirmation on 11.54. Yeah, one more? One more person.
Yep.
My head's too big.
Not 5.
Yeah. Okay. So, but we all agree 11.5554 perfect units. Okay. So now we reviewed everything. Well, that was grade 10. Is that all you guys did in grade 10 for trig, basically? Wow. Like, don't you just feel like we could have taught that in like an hour?
That's true.
But you guys do like a whole week. I mean, like, obviously you need to practice, but like, that's what I mean. Like, that's grade 10, and it's like we could have reviewed it in 5 minutes. Could have taught it to you in definitely like 30 minutes. Probably better than, yeah, it definitely could have been done. And it's like, so in grade 11, it's like every day something new. Like, there's no more units like that. A lot of wasted time in the grade 10 course. Anyways. Okay, so now we're gonna look at trig in a completely different way. Sort of keeping an eye on the time. I'm just gonna quickly introduce this to you. We're looking at trig in a completely different way. We're gonna be talking about something called the unit circle. The terminology we're gonna use is gonna be completely different. So we're gonna be putting it in terms of like x and y and r, instead of whatever you guys did in grade 10. Basically, we're putting it in a coordinate system. Is basically what's happening. So like you guys know the Cartesian plane, right? So if you define the origin as sort of the starting point, and then you just have like an r value like this. Okay, we call it r for this reason, because we use it to describe circular motion or circles. So if you were to rotate this, what's called a radial arm all the way around 360 degrees, you would get this circle. So now does it make sense why it's called r? What do you think the r is for? Perfect, you guys are so smart. So r for radius, okay? And then we say, okay, let's define a point on the circumference of this circle. Let's call it point xy. Well, now I can start talking about a triangle. Just check this out. Drop that down. What is this, x or y?
Why?
It's y, right? Because I dropped my marker. Because yeah, from here to here would be the y value, right? So we say, oh, that's y, and then that's just your x, right? Because you're always starting from the middle, the origin, so that's just whatever the x coordinate is. And hey, by the way, that's a 90 degree. And oh, we were talking about rotation, so we usually start on the x-axis and we define rotating that way. So counterclockwise is being positive, and we say rotate theta degrees, and now you have your grade 10 system in a new way. Does that sort of make sense? I think it's the best I've ever explained it well. So let's reconstruct all the ratios. So if we're using these letters, let's see. Well, sine theta would be opposite over hypotenuse. So now it's y over r. And if you check your formula sheet, you'll see that. Cos theta, so here's theta, that's adjacent over hypotenuse. So it's x over r. And then tan theta, well, that's opposite over adjacent, so that's y over x. Interesting. We can solve these for x and y. So if we quickly need to figure out what y is, well, if we multiply both sides by r, then we can say r sine theta is y. Same thing here, we can solve this for x, so if we multiply both sides by r again, now you get that r cos theta is x. Now, we don't really use tan because it's got both, but you could solve for y or x and tan, but we generally only talk about sine and cos. It's just more convenient, right? Wow, that's interesting. So let's see. We have a brand new way of thinking about trig. No more SOHCAHTOA, it's just y and r and x. I called r the terminal arm, so this is called the terminal arm. And as we go through this lesson, you'll see that we can kind of phrase some problems using this terminology, and it's way more convenient than whatever you guys learned in grade 10. Any questions up till here? It's really important that we like understand the notation and like the reasons why. You'll be drawing this a lot. Any questions so far? It's great. You guys are smart. One more thing, I'm not sure if you've learned this yet, but we call this quadrant 1. Is this something from grade 10? I can't remember. That's quadrant 2. This is quadrant 3. And so I'll be referring to the quadrants, 1, 2, 3, 4. Yeah. I think that's pretty much everything. That might be. Well, let's do one question. We'll do the first example just to wrap it all up nicely. So I'm going to erase this if everyone's cool. Excellent. So before we get crazy, let's just do one sort of grade 10-y type problem, exercise, let's say. So it's example 1, you guys have it. So I'm not going to redraw anything. I might redraw the picture here. So I think you guys have something like that going on. And it just says the point 47 is on the terminal arm of an angle theta in standard position, right? By the way, this is called standard position. So what you're going to do is you can see that point 47, which quadrant is it in? 1, 2, 3, or 4? 1, perfect. So you'll just kind of do a sketch. So you just go like that, and you'll go 0.47, and you'll construct your triangle. So you'll call from the x-axis to the terminal arm theta. This is the x value, which would be here, right? That's your x-axis, that's 4. This is 7 right there. And then call this r, and we don't know what it is right now. So it just says, determine the distance r from the origin to the point P. So remember, the origin is right here. That's the point 0, 0, origin. Okay, why is it called the origin? Well, that's where we're starting, so it's the origin. Interesting. Okay, so part A, find that distance. So what are they really asking me for here? You guys learned it in hypotenuse? And what's the formula called? Yes! So another thing that gets reframed in our whole new way of thinking about this is no longer is it a squared plus b squared equals c squared. It's, what is it? It's the 2 sides squared equals the hypotenuse, right? So it's x squared plus y squared equals r squared. So that's what you'll see on your formula sheet. So let's go pop it in. 4 squared plus 7 squared equals r squared. So we get 16 plus 49. I'm going to go ahead and square root both sides. Okay, so we got to square root both sides, right? So what do we get? 59, 65, square root of 65. Here's the good news. If it's not a perfect square, you get to leave your answer like that. Ain't that good news? Sorry? Because this is precise. We're not going to be rounding any decimals, so we want to keep all that precision. NASA lost the probe, was it back in the 70s? Because of a conversion error, because of decimals basically, right? Like when you take a really small number, like say, you know, like how we get so crazy about science, like say like you have a rounding error on this, okay? Well, in space, distances are like this big. You know, like this is like a small distance in space, like I don't even know. So it's like, yeah, take your small tiny rounding error, multiply it by a gigantic number, and oh, you just missed that planet by thousands of kilometers or something. Like that's what happened. Isn't that crazy? That's why we're so obsessed with like representing numbers precisely. Interesting. The science is interesting if you really get into it. It's just like school, we bore you to death. Anyway, part B. Determine. You guys like that? I can sing. My kids hate their parents singing. Like if I sing, my kid will be like, "No, Dad, no." And then like if I hear my mom sing, like to this day, like she's singing, it just like makes me angry. I'm like, stop singing. It's hilarious. Anyways, okay, so determine the primary trig ratios. Well, you know, are you okay?
Yeah, I'm alright. I'm just sick.
So what's sine theta? Do you remember? What was it? Something over r.
So opposite
Y.
Y, very good. And then cos theta?
X over R.
X over r, and then tan theta y over x. I'll show you some tricks later how to remember, but so sine theta, well, y was 7, so you go 7 over square root 65. Good news, we don't care about rationalizing, so you can leave it like that. I don't know why we spend so much time in grade 10 and then we don't care in grade 11, but anyway, cos is 4 over square root 65. Tan theta is 7 over 4. Okay, that's part B. Part C is just determine the angle. So, $1 million question. Will all the ratios give you the same angle?
Yes.
Yes! So pick one, any one. I recommend using tan because that was given in the question. So if you mess up your calculation, like this was given in the question, it's not going to be wrong. Okay, so let's use that. So to find the angle, you go inverse tangent of 7 over 4, right? Because on the table, you'd be reverse looking up that and going back to the angle. So you're going backwards, inverse. And I got, to save you some time, 60.2. And that's a great place to stop. Mr. Hartle. will take you from there. Thanks for joining us.